Okay, welcome to the video, Unit 2.2a, Solutions Chemistry video. This is part 3. In this video, be sure to annotate. There's also some supplemental videos attached, so be sure to look out for those. All right, in this video, we're going to learn about net ionic equations. And they're useful because they simplify double replacement reactions to the most essential information. So basically, what is most important about that double replacement reaction. There are similar processes for doing it for no matter what's the case, whether you're doing an acid-base reaction or a precipitate reaction. The cool thing about acid-base reactions, their net ionic equation, if it's a Bronsted-Lowry acid and base, always looks the same. It always has H plus OH minus going to form water. For precipitate, it looks similar. It has an anion and the Ca2 ion. So that's an example here. So check to make sure things are going well. Okay, great. Let's take a look at this example here. Ionic equation example 1. There are 3 steps to net ionic equations. The first step is to write the molecular equation, and that's the equation that we normally see. So, for example, if you were told we're combining potassium chloride and silver nitrate together, what would the products be? And you may or may not recall from the previous video, you would write down your reactants first and then do the exchanging to figure out what the products are. Once you've done that, you have to use solubility rules to determine if your products are aqueous or solid. We know the reactants are going to both be aqueous because they're telling us they're 2 solutions, but the product's not so easy. So we look at the product here. One of the products is potassium nitrate because we exchange the potassium and the nitrate, and we know that all group 1 metals are soluble. So anything that's soluble, meaning that it dissolves, we're going to write as phase as aqueous. So this is going to be aqueous. You can also think of it as all nitrates are soluble. So again, we know that this will be soluble, so its phase is aqueous. This one sort of is a double whammy. Group 1 are, but it's all the work. Ag plus, potassium most fun ion on the reactant side, not cross it as an ion, so Cl. Note here the plus the water, and acid and the sodium chloride. Someone said, hey, we can break that. Just water. We're going to do now Cl minus cross. And remember, as I said, equation was ready for us in the assignment when you did this thing. However, when you got an equation, then complete ionic, it's the same thing. All right. Hope you follow today.